Imagine you send money to a friend using your banking app. In the background, your bank quietly checks everything before the transfer completes. It checks whether you actually have enough money in your account, whether the receiver is valid, and whether this transaction looks legitimate according to its internal security rules and policies. Now imagine sending cryptocurrency to someone instead. There is no bank checking anything in the background. There is no company managing the system, and there is no central authority responsible for approving or rejecting your transaction. So this brings us to the most important question about blockchain technology. If there is no bank involved in the system and no central authority managing transactions in the background, who actually verifies your payment and decides whether it is valid or not? Because without someone checking transactions, anyone could send money they do not have or try to cheat the system without being noticed. To understand how this works, we need to understand 4 simple concepts that make blockchain technology possible. These concepts are called the ledger, the block, the hash, and consensus. These 4 elements work together to create a system that can verify transactions automatically, without needing to trust a bank or a company to manage everything in the background. Let us start with the ledger. A ledger is simply a record book that keeps track of transactions over time. It shows who sent money, who received money, and how much money was transferred between them. Every financial system in the world needs some kind of ledger in order to keep track of ownership and prevent people from spending the same money more than once. Banks already use ledgers in their own systems every single day. Every time you make a payment using your credit card or send money to someone else, that transaction is recorded inside the bank's private database. This private ledger is stored on the bank's own servers and is fully controlled by the bank itself. The important thing here is that this ledger is completely controlled by the bank. The bank decides which transactions are recorded, which ones are rejected, and when records should be updated or changed if necessary. This means you must trust the bank to manage this ledger honestly and accurately at all times. Blockchain uses a completely different type of ledger. Instead of being private, it uses something called a public ledger that anyone in the world can access and view at any time. This ledger is not stored on one single server, but is instead shared across thousands of computers around the world. Because the ledger is shared across many computers, no single person or company owns the system. This also means no one can secretly edit or manipulate the transaction records once they are added to the ledger, without the rest of the network noticing the change immediately. However, transactions are not added to this ledger one by one in real time. Instead, new transactions are grouped together over a short period of time before they are recorded permanently into the system. These grouped transactions are stored inside something called a block. A block is basically a digital container that holds a list of recent transactions that are waiting to be permanently recorded on the blockchain. Instead of recording each individual transaction immediately, the network temporarily collects multiple transactions and stores them together inside this container before they are added to the shared ledger as one unit. Grouping transactions into blocks makes the system more efficient because it allows the network to process many transfers at the same time, instead of handling them individually. This batching process also helps maintain the order of transactions and ensures that every payment is recorded correctly according to when it was made within the network. Once enough transactions are collected, a new block is created that contains all of these recent transfers. This block represents a short period of transaction activity and becomes the next candidate to be added permanently to the blockchain once the network agrees that everything inside it is valid. After a block is created and verified, it gets connected to the previous block that was already added before it. Every new block becomes permanently linked to the one that came earlier, forming a continuous chain that represents the entire transaction history of the network from the beginning. This chain structure is extremely important because it prevents anyone from secretly modifying past transactions. Since each block depends on the previous one in order to remain valid, changing something in an earlier block would affect every block that comes after it in the chain. In part 1 of how blockchain actually works, we took a closer look at the ledger and how blocks store transactions on the network. In part 2, we'll continue by exploring how hashes protect the data and how consensus allows the network to agree on what gets added to the blockchain. Make sure to follow along so you don't miss it.